Okay, this is an application problem. In this problem, they have given a vertical chimney of circular section of 400 diameter. So joints a roof slope at 35 degree. So to the horizontal, the shortest portion of the chimney over the roof is 300 Determine the slope of the sheet metal. Here, the mentioned scale is 1:10. That means the 400 diameter will be converted into 40 and the 300 height of the shortest portion of the chimney is converted into 30 Okay, so first we are going to write the scale here. So it is somewhat like an circular cylinder, but we need to cut it with respect to the 30 degree from that horizontal plane. Okay, it is easy. So first you can draw an XY line. So here the circle in the top we have to draw for a diameter of 40. So you can give the diameter 40, and now you divide the circle into 8 equal parts using thin lines. So you can divide the circle into 8 equal parts by taking an angle of 45 degree. So you can give the angle 45, 45, 90 and 135 and 180. Okay, this is the angle you have to choose. One 35 and 180. Using extend to next, you can extend these lines. Okay, now you can write down the notation for the top face and the bottom face. So drawing the projection lines to draw the front view. So here in this problem they have not given an height distance. So randomly we will take the height. Okay. Randomly height will be taken in the front view because we don't know the exactly the height length. Okay, now we have to take this 35 degree angle line. You can see in the question. Okay, section plane angle you can give. There is 150 give, it will take 30 degree. Okay, Now from this end, the shortest portion they have mentioned 30 mm. So from here, so from this end, okay, we have to consider 30 mm. So give type 30, okay. Then here you connect. So this is what the height of the chimney, okay. This is what the height of the chimney. The upper portion we should erase it. Using trim command, I am going to remove that upper portion, okay. So you can show the dimensions here. Angle 30 degree, the length 30 mm for the shortest portion from the horizontal, okay. Now I am going to split it that upper portion using split command, so that I will be highlighting that upper portion. Okay, that's what the remained upper portion of the vertical chimney. So using a split command, I am going to split it to the exact length here, okay. We'll be making that as thick here, okay. Now it is the concept wise it is similar to your cylinder, okay. Now writing the front view notations. So here the front view notations are little jumbled, no need to worry. So you try to understand the concept here, that is most important, okay, because this is an application problem. You can see the prism and cylinder will be development constructed using parallel line method. That's why I draw on the parallel lines. So here the total length it is pi d. You know that for the cylinder diameter it is 40. So multiply with the pi value, you get it around it is 125.6 something. Okay, pi d value. So using this offset command, you give the distance 125.6, so you get the total length, okay. Now we have to divide this into 8 equal parts. So divide this 125.6 divided by 8, so you will get the length here. You can use the calculator, okay, to find out the length. 125.60 divided by 8, you do it, you get the length. The length you can type it here, it is 15.62, okay, and offset it to the required length here. You can see it has been equally spaced here. Now you can write down the notations. So you can write it in capitals here, capital letters, capital A, B, C, D. So you can subscribe for the channel, hit on the bell icon for the latest notifications, and share it to the maximum students so that they can be benefited from this. Now you can at the section point you can mention the numericals here. 1, it is cutting at the vertical edge AA. 2, 3, 4, and everything is cutting exactly on the vertical edges. Okay, so 5 again here written back, 6 on FF, 7 on GG1, and 8 on HH1. Okay, now we have to just project the horizontal lines from this point 1, 2, 3, 4. So we can have to write it correctly. Let's project it. It is cutting exactly on A and A. Okay, so we can mention it, 1 here and 1 here also. Same way we project it 2. So 2, it is exactly cutting on the vertical edge B and H. We just extend it so that it will be convenient so that to write the exact number. Okay, so you can mention it is 2 here, and here also you can mention 2, 8 here, sorry. The same way we project the point number 3. So point number 3 on C, and it is extended till G here. Okay, that is your 3 and 7. Now we can extend this 4 and 6. Okay, yes, this is what we have. The 4, this is 4, and this is 6, and a 5 we are getting exactly on the E point here. Okay, now using curve command we have to connect all this from 1 to 1, that is from 1, 2, 3, 4, 5, 6, 7, 8, 9. So using this curve command we have to do. Okay, you have to use curve command to make sure you join it correctly. I think curve command is not selected here. Okay, select the curve command. Yes, from 1, select the thick line. Take exactly the intersection point. Okay, I think joined wrongly here. It is 2, it is falling above F8. Okay, I think I will redraw it again. So I'll be starting from 1 here. So go to curve command, starting from 1, and 2, it is on the vertical edge B, 3, it is on the vertical edge C, and 4, it is on vertical edge D, and 5 exactly falling on the E here, and then 6, 7, okay, and 8 and 1 you have to join. Okay, that's what. In the upper portion also we should make it dark here. I'll select the thick line. Okay, so this completes the problem. This completes the vertical chimney problem. Thank you for watching the video, and share it to the maximum students so that they can be benefited from this. Subscribe for the channel and hit on the bell icon for the latest notifications.